Phototransduction begins when a photon, also known as a particle of light, is concentrated through the lens and focused in the retina. The retina is a thin layer at the back of the eye where rods and cones are found. The rods detect the light, and the cones can detect the color. Main things in rod cells. Rhodopsin is a visual pigment which is made up of the proteins opsin and 11-cis-retinol. There is also phosphodiesterase, also known as PDE, that has 2 alpha subunits connected to it. The transducin, which is a G protein with 3 subunits, alpha, beta, and gamma. The goal in phototransduction is to get the PDE on its own, so we'll need to remove the alpha subunits. If the binding spot is exposed, the opsin makes its way over to the transducin. The reaction catalyzes, converting GDP to GTP. This disconnects the alpha subunit from the transducin. The subunit then goes over to PDE and removes the other alpha subunits. This process is repeated to remove the other subunit from PDE. Getting the PDE by itself, it activates and begins converting cGMP to GMP. In state of rest, the rod cell is depolarized. It is depolarized because there is a cGMP channel that lets calcium and sodium go through the membrane. When PDE is activated and starts to convert cGMP to GMP, then there is nothing to hold the cGMP channel open. Now that the channel is closed, the charge of the cell changes. With the new voltage, the potassium channel is open, allowing potassium to freely flow through, causing the cell to hyperpolarize and make it more negative. This causes the cell to start sending transmitters to the brain and signaling that there is light. Stops receiving a stimulus. The protein kinase G comes and keeps the rhodopsin from activating any more G protein. Allele cyclase then converts GMP to cGMPs. Last step is activating the sodium-potassium-calcium exchange pump, which brings the cell back to its state of depolarization.